Hello everyone and welcome back to PostNetwork Academy. If you are passionate about data science, artificial intelligence or machine learning, you are in the right place. I am Bindeshwar and today we are diving into an essential concept in probability, discrete random variables and probability mass functions. So let's get started. So a random variable is said to be discrete if it has either finite or countable number of values. Either it is a finite or countable number of values. So what does countable means? Countable values are those which can be arranged in sequence or corresponding to natural numbers. That means 1 1 and onto to natural numbers. So example is number of students present in each day in a class. Finite. Now let x be a discrete random variable and taking values x1, x2, x3, xn. So the probability mass function that is defined at the value of xi, that is a random variable, and you will write p x's. It satisfied conditions that probabilities are non-negative for all i's, these are non-zero for all i's, and summation of all probabilities that would be equal to 1. So let us check that whether it is a valid probability distribution or not. So for the value of x is equal to 0, here x is equal to 0, px is 1 upon 2, and for x is equal to 1 we have px, that is 3 upon 4. So see that here, let us check px. Here x is equal to 0 plus px is equal to 1. So that would be equal to 1 upon 2 plus 3 upon 4, and that is greater than 1. So that is not a valid probability distribution. Let us see that. So that is greater than 1, so that is not probability distribution. Now find the constant c in the given probability distribution. So here x assumes from 0 to 4, and here probability that c is again c, 2c, 3c and c. So see that, as we know that here c, c, 2c, sum of all probabilities would be equal to 1, and this will implies that 8c is equal to 1 and c is equal to 1 upon 8. That is very simple. So basically it has happened like this one: p x is equal to 0 plus p x is equal to 1 plus p x is equal to 2 plus p x is equal to 3 plus p x is equal to 4, and that would be equal to 1. So the same way it is explained. So c plus c C plus 2C plus 3C plus C, that is equal to 1. And this implies that 8C is equal to 1 and C is equal to 1 upon 8. And here you can also see the same thing. Now let us see the next example. Find the probability distribution of the number of hits when tossing 3 fair coins. So number of hits, that is your random variable. So 3 fair coins are tossing. So the sample space would be this. There are 8 sample points and number of hits that is defined. So x can have 0 values, and that is, you can see that only one sample point, t, t and t, and x is equal to 1. Just count it. This is 1, 2 and 3. So there are 3 h, t, 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 h, t and t, t, h. So for x is equal to 1, that means there is one head. So there are 3 and that is 1. And for x is equal to 2, again we will have 3. So this one and this one. So h, h, t, h, th and thh, that is 3. And for x is equal to 3, that means all 3 are hits, so only one sample point. So h, h and h, and that is 3, not 3, that is 1, only one sample point. So what we need to find? We need to find probability distribution. So see that here, just draw here the value of x when 0, so px here. So 0, so there are one sample point, one favorable point, so that would be, and at its size of sample space is 8, 1 upon 8. For a 1 there are 3, so 3 upon 8. For a 2, that is again 3 upon 8. And for a 3, the value of 3, you have only one favorable case. So this is probability distribution. And see that when you add p x is equal to 0 plus p x is equal to 1 plus p x is equal to 2 and p x is equal to 3, so that will come 1 upon 8 plus 3 upon 8 plus 3 upon 8 plus 1 upon 8, and if you add, that will come 1. Now see that the same thing I have done here. Now let x be number of hits. So possible values x is equal to 0, 1, 2 and 3, and this way what I have done already. So this is the probability distribution when 3 fair coins are being tossed. Now let us see example number 4, and little bit interesting. So a random variable x assumes the values -2, -1, 0, 1 and 2, and there is equations are given. these all are equal, and that is equal to P, the first equation. And the second is this one, P, that is x is less than 0 is equal to P, x is equal to 0 and greater than. So see that here, if we add, that is less than or equal to, less than, this expression is equal to Px is less than 0. So I am writing here basically this is Px is less than 0, and here Px is equal to 0 already written, and this part is Px is greater than 0 because the value of x is 1 and 2. So greater than 0, this is less than. And see that this is equal to P. So P plus P, that is equal to P, x is equal to 0, and here also P plus P. So P 2P, that is equal to P, x is equal to 0. 2P also, that means P x is equal to 0 is 2P, right? And this all you can say that the value of x, that P x is equal to minus 2 plus P x is equal to minus 1 plus P x is equal to 0 plus P x is equal to 1 plus P x is equal to 2, and their sum should be equal to 1, and this is P, that is P, this is 2P. From here you can see that, and that is again P and P, so that would be equal to 1, and from here you can see that 2P, 2P and 2P, 6P is equal to 1. So P is equal to 1 upon 6. Now let us see that the same thing here. Since total probability is 1, so 6P is equal to 1 and P is equal to 1 upon 6. Now see the probability distribution. Why for minus 2 it is 1 upon 6, for minus 1 1 upon 6, for 0 2 upon 6, for the value of x 1 it is 1 upon 6, for 2 also 1 upon 6. So hope you understood all the examples. Let us conclude. A discrete random variable has countable values. That means there is 1, 2, 1, 1 and on to mapping to natural numbers. Probability mass function must satisfy these two values. That means these two conditions. All probabilities must be non-negative, and summation of all probabilities must be 1. You can also visit website for more resources, YouTube channel for videos and playlist, Facebook page, and you can also connect to LinkedIn page of PostNetwork Academy. So hope you understood. Thanks for watching the video.